So today in this video we will be studying about the defects of vision and their correction. We know that the human eye has the power of accommodation, that is, the lens of the human eye has the capability to change its focal length depending upon the fact whether the object whose image needs to be formed is closer to the eye or far away from it. And with the help of that, the eye can see distinct objects clearly at a distance of 25 centimeter or more from the eye. However, sometimes the eye may gradually lose its power of accommodation. In such conditions, the affected person cannot see the objects distinctly and comfortably, and his or her vision becomes blurred. There are three common refractive defects of the vision which are mentioned below. Number one is the myopia, known as nearsightedness or sometimes referred to as short-sightedness. Number two is the hypermetropia or long-sightedness, and the last one is the presbyopia. Let's discuss about them one by one in great detail. Number one is the myopia or the nearsightedness or short-sightedness. As the name suggests, a person suffering from myopia can see the objects that are situated near the eye clearly, but is unable to see the distinct objects distinctly. See, there are 2 points of human eye. One is the near point and one is the far point. The far point is the infinity and the near point is known as least distance of distinct vision, which is approximately 25 centimeter. What happens in myopia is that the near point is situated correctly at 25 centimeter, but the far point is not present at infinity. In fact, it is shifted to a point which is much closer than infinity. Like in this particular case, the figure shows that this A figure. In this particular case, the far point has shifted from infinity to point O, implying that the person can only see the distinct objects that are lying at a maximum distance of x from the eye. In fact, far point for a myopic eye has shifted nearer than infinity. This is what I already just explained. For a myopic eye, the image of a distant object is formed at a point I dash in front of the retina. So this is the actual case of when, as I already told you, that far point has been shifted from infinity to point O. But what if the object is actually lying at infinity? In that case, the image is not able to be formed at retina. It is formed in front of the retina, indicating that the person will not be able to see this particular object clearly and his vision will be blurred. The main causes of myopia are primarily two. Number one is that the curvature of eye lens is excessive, as a result of which the focal length of the eye lens is too short or the eyeball is elongated. The distance between the eye lens and retina is increased. You can clearly see that the lens seems to be a bit thicker in this particular condition. Now let's talk about its cure, or we can say the correction for myopia, because there is no such cure. The correction is implied by the spectacles or by contact lenses. So myopic defect can be corrected by the use of a concave lens of suitable power. The concave lens forms a virtual image of the distinct object at the far point O of the myopic eye. You can clearly see in this figure 2.3c. They have placed the concave lens in front of the eye lens. This concave lens is actually fitted in your spectacles. So the rays diverging from point O are now focused by the eye lens to form the final image eye on the retina, which is better than the previous case where the image was forming in front of retina and not on the retina itself. Thus, the person can now see the distinct objects clearly and the myopia defect is corrected. Moving on to the next problem or the next defect, that is hypermetropia or the long-sightedness. A person suffering with hypermetropia can see the distant objects comfortably and clearly but is unable to see the nearby objects distinctly. For a hypermetropic eye, the far point is situated at infinity, but the near point is not at 25 centimeter. This is actually opposite of what we studied in myopia, that the far point is at infinity only, but the near point is shifted away from 25 centimeter. For a hypermetropic eye, the image of an object situated at N, the least distance of distinct vision for a normal eye is formed at point I dash behind the retina. You can see here that the near point is shifted from 25 centimeter, more than 25 centimeter actually, and the image is being formed behind the retina. The causes of hypermetropia are again that the curvature of eye lens is too small, as a result of which the focal length of the eye lens is too long, or the eyeball is shortened. That is, the distance between the eye lens and retina is too small. Talking about the correction for hypermetropia, in this particular case, it is corrected by the use of a convex lens of suitable power. So what this convex lens does is it forms a virtual image of the object situated at N, the least distance of distinct vision for a normal eye, at the near point N dash of the defective eye. The rays diverging from N dash are focused by the eye lens so as to form the sharp image on the retina. So, of course, this is better than the previous case where the image was forming behind the retina. As a result, the person can see the object situated near the eye at 25 centimeter distance distinctly, and the hypermetropia defect is corrected. Last one is the presbyopia. This is actually similar to hypermetropia but with a slight difference. Let's see what is that difference. With the aging of a person, the flexibility of the lens of his eye gradually goes on diminishing, or you can say decreasing, because the ciliary muscles are also weakened. As a result, the power of accommodation of the eye usually decreases. Now, why this happens? See, ciliary muscles are the muscles that help the lens to adjust its focal length. Now, if ciliary muscles are weakened, that means that adjusting capacity of the lens has decreased or reduced. So, most people when they are aged find it difficult to see the nearby objects comfortably and distinctly. This defect of vision is called presbyopia. The effect of presbyopia is same as that of hypermetropia, but the cause is different. And presbyopia can be corrected by using again convex lens of appropriate power. Now, there are a few cases where the old person may suffer from both myopia as well as hypermetropia. Such a person requires bifocal lenses. The meaning of bifocal lenses is that a lens that consists both of the concave as well as the convex lens. The upper part consists of a concave lens and it facilitates the distinct vision by correcting the myopia, and the lower part consists of a convex lens which facilitates the near vision by correcting the hypermetropia. Here is the picture of spectacles with bifocal lenses. This is for viewing the far off objects and this is for viewing the nearby objects. This is the upper part corresponds to the concave lens which helps to see the far off objects, and the lower part consists of the convex lens which helps in visualizing the nearby objects. I hope this topic is clear to you. Thank you.